Hi everyone, welcome to you my class. Today in this class I am going to explain you about earthwood machine. Students, before going to it, everyone must know about earthwood machine. What is earthwood machine? Who invented by it? That means here earthwood machine is a device student. It is used to verify the classical mechanical laws of motion with constant acceleration. This device was invented by the George Atwood. Who is that students? George Atwood in 1784 students. The device Atwood machine was invented by George Atwood in 1784. It verifies the classical mechanical laws of motion with uniform acceleration. Students, considering the ideal Atwood machine, here in this ideal Atwood machine, two blocks of the masses are M1 and M2, which are connected with a massless, inextensible string. It passes over a smooth pulley, considering the pulley is massless. This arrangement is hangs with the help of a rigid support as shown in the students, as shown in the figure. Students, see here, this is the instrument simply. It is laboratory operator. Students, here this is pulley, this pulley having massless, and this string which is connected to M1 and M2 also massless. Pulley is frictionless. And also one more string is there which is connected with the help of the rigid support to the pulley students. Here, by using this device, we should calculate the acceleration of the system, means blocks, and also tension developed in the strings, this string, and also here this is assuming that capital T, and here also capital T. Tension developed in the string which is connected to the pulley and the ceiling students. These are the values which we find out here students. Mostly acceleration. How much the acceleration is developed here students. For that, we must draw the ABDs of the two blocks first. ABD of M1. See students. Before going to it, one more thing I want to tell you. Considering M1 is more than M2, that means M1 moves downward with an acceleration here, and M2 moves upward with the same acceleration here students. Now take the ABD here. This is M1. Okay. Due to gravity, M1G acting vertically downward and tension T considering upward, and the block moves downward direction students. By using Newton's second law, F net is equal to M into A. See here students, F net means driving force, that is M1G minus opposing T is equal to, see here, M1G minus T is equal to M1A. Assuming this is equation number 1 students. Okay. Then after, draw the ABD of block 2. ABD of block 2 here. ABD of m2. Okay students, see here, this is m2. Due to gravity, this weight acting vertically downward and tension always acting opposite to away from the pulley block, and this block moves upward direction. Write the equation same as F net is equal to ma. From that, driving force is tension and opposing force is m2. G is equal to m2 into here. This is equation number 2 students. See equation number 1 and equation number 2. Student, while substitute the values of these in F net is equal to ma, you must write or you must consider the driving force first. Driving force means in which direction the block moves, that force students. And then after opposing force, opposite to the direction of the motion it acts. So these two forces we must consider here. Then after we can substitute. See here, driving force minus opposing force. This is the net force is equal to ma. Here also driving force minus opposing force is equal to ma students. Okay students, see these two equations. After this, we can add equation number 1 and 2 students. We can add 1 and 2. After getting the result of these two, see here students, minus t plus t get cancelled students. Minus t plus t get cancelled. Then the result is m1g minus m2g students. And also right side of the equation, m1a plus m2a students. Remember students, while adding the two equations, you must have considered that left side of the equation is added to the left side of the next equation. Right side of the equation is added to the right side of the next equation. Then only you will get the correct. See here, adding these two equations. We can add the equation number 1 and 2 to get the result. T get cancelled. m1g minus m2g is equal to m1a plus m2a students. From this, taking the g common and here taking a common. So from this students, a is equal to m1 minus m2 of g whole divided by m1 plus m2. This is the acceleration of the system students. See that equation properly? See that? See the students. Next students, substitute this A either in equation number 1 or equation number 2. You will get the tension students. What is the tension? See here. From equation 1. From equation number 1, that is m1g minus t is equal to m1 into a. m1g minus m1a is equal to t. Now we can substitute the values here students. m1 of a means students m1 minus m2 of g divided by m1 plus m2 is equal to t. Simply here students, I can substitute the value of a in this place students, just replacing the a value. Now assuming here denominator is 1. Then after students, taking the LCM of these 1 and m1 plus m2, we get the LCM is m1 plus m2 because this is 1, m1 plus m2 into 1 students. So by simplifying it, m1g of m1 plus m2 this value minus of m1 of m1 minus m2 g is equal to t students. Simplifying these students. See here simply m1 square into G, and here m1 m2 into G, and here also minus m1 into m1 square into G, minus of minus plus m1 m2 G whole divided by m1 plus m2 students, whole divided by m1 plus m2. See, minus m1 square G plus m1 square G, both they are cancelled with each other, then we get the result here. See here, look at the board. This is equal to T actually. So here T is equal to, adding this m1 m2 G, how many m1 m2 G's are there? 2. So that 2 m1 m2 G divided by m1 plus m2 students. This is the tension developed in the string which is connected to the two blocks, passes over the pulley students. Okay students, here then after we can also find out that tension developed in the string that is connected to the pulley students, and see, for that take the FPD of pulley. This is massless pulley students. What is that? Massless pulley. So by taking the FPD of that pulley, here this is T and this one is also T, and here the string which is connected to the ceiling and this pulley is small t. Here this is massless students. So consider it here according to Newton's second law of net is equal to m into a. Here massless means considering this term is 0 students. Now here in this instant we can write T minus T plus T, 2T is equal to 0 because they are massless students. And finally we get that T is equal to 2 into T, small t is equal to 2 into capital T. Already find out that m1 m2 G, 2 m1 m2 G by m1 plus m2. And finally small t is equal to 2 into 2, 4 m1 m2 G by m1 plus m2 students. So these are the values which we found that here students. Okay, this is tension. What is that students? Tension. This is tension developed by the string which is connected to the ceiling and the pulley, and this is the tension developed by the string which is connected to the two blocks. And also students, acceleration, already find out that m1 minus m2 of G by m1 plus m2 students. So now here students, I am going to explain you one example based on this concept students. See here students, this is 6 kg and this is 4 kg students. One is 6 kg and another one is 4 kg. As usual, here find out that acceleration, tension T, small t students. These are the values which we find out this example. This is assuming that just example to know how to do the problems students. How to do the problems based on these examples you must know clearly. Okay, see here. Already told you advantage are the use of the earthwood machine. It verifies the laws of motion students. Okay, moving with constant acceleration. Based on that I already derived this acceleration, tension and the small t already derived students. So based on those formulas we should find out now values here. For that, first solution students is that given that m1 is equal to 6 kgs, m2 is equal to 4 kg students. Assuming that G is equal to 10 meters per second square. Now we know that acceleration A is equal to m1 minus m2 of G by m1 plus m2. That means A is equal to, this is 6 minus 4 of 10 by 6 plus 4 students, 10. 10 get cancelled. We should get the result is 2 meters per second square students. This is the acceleration. Okay students, right? This is the formula to find out the acceleration at this concept. And also tension students. What is that? Tension again. Tension T is equal to 2m1 m2 G by m1 plus m2. Here T 2 into 6 into 4 into 10 by 2 into 6 into 4 into 10 by 6 plus 4, 10. 10 get cancelled students. We should get the result is 48 newtons. Check this. Also small t students, small t is equal to, here instead of this we can write 4 m1 m2 G by m1 plus m2 students. Substitute those values here, we get the result is 96 newtons. Or 2t, it can also be written as 2t students. T is equal to 2t code right C. I hope you understand about the concept of applied motion students. Thank you.